In today's video, we're talking about Chapter 3, Section 1, Inequalities, and Chapter 3, Section 2, Solving Inequalities by Adding or Subtracting. So let's get started with some notes. Write this down. When you are talking about inequalities, if you're trying to graph them, you need to indicate whether it's just greater than or less than, and the way we do that is with what I call an open circle. Or you also need to indicate if you have greater than or equal to or less than or equal to, and you would indicate that with a closed circle or a dot. Okay, so let's practice graphing some of these. Here we have y is less than 3. Since this is just a less than sign, I know that it's going to be an open circle, so I put the open circle on the number 3. And then since it's less than, I want all the numbers that are less than 3, that would be 2, 1, 0, negative 1, so on and so forth. So I would draw my line going this way. My number line stops at negative 7, but obviously there's numbers less than 3 that go beyond negative 7, so we need to indicate that by drawing an arrow at the end of the line, indicating that that goes on forever. So that's the graph for y is less than 3. Let's do one more of these. G is greater than or equal to negative 6. So on negative 6, I'm putting a circle, and I have to determine whether it's going to be open or closed. Since it is greater than or equal to, it's going to be a closed circle. And then I want all the numbers that are greater than or equal to negative 6. So that would be negative 5, negative 4, so on and so forth. So I'm going to the right. It does not stop at 7, even though my number line stops at 7. So I draw the arrow to indicate that goes on forever. All right, now the reverse direction. If I give you the graph, how could you write the inequality based on the graph? So first of all, pick a variable. I will choose x. Doesn't matter what letter you pick. Then I have to determine my inequality sign. First of all, will it be less than or greater than? Since this is going to the left, I want all the numbers less than 3, so I'll do a less than sign. And then I need to determine, is it underlined or not? Well, since this is a closed circle or dot, I want to underline it. And then the number here that the dot is on is 3, so I just put a 3 here. So this inequality, the graph of the inequality, is here, and the inequality itself would be x is less than or equal to 3. One more of these. Okay, now again, pick a variable. I'll do y this time. Is it greater than or less than? Well, since my arrow is going to the right, I want all the numbers greater than negative 1, so it would be greater than. Now this is an open circle this time, so I do not underline it. And my number here is negative 1, so I put a negative 1. All right, now let's jump to Chapter 3, Section 2, where we're actually solving the inequalities. Okay, so pretend like n plus 8 is greater than or equal to 19. Pretend like that was just n plus 8 equals 19, because we solve it the same exact way. You separate your two sides. The inequality sign, though, is separating our two sides as opposed to the equal sign. And then the variables on the left, along with the 8, they're attached with addition, so the inverse would be to subtract 8, and I need to do it on both sides. Bring down the n. The 8 minus 8 cancels. But it's different from this because instead of an equal sign now, I have a greater than or equal to sign. So that's the symbol I need to use. And then 19 minus 8 would be 11. So I think that the answer is n is greater than or equal to 11. The only difference between equations and inequalities is that when you go to check it, write this down, not only do you need to check the answer, which is what we're used to, you also need to check the inequality. So I'll show you how to do that. When we check the answer here, we just want to check, was 11 the correct numerical answer? So I plug in 11 in place of n. And I want to see if these two sides are equal, just to check if my numerical answer was correct. So 11 plus 8 would be 19. This is obviously 19, so 19 equals 19 is correct. Okay, that's the basic part. Now when we go to check the inequality, what I want to do is go back and look at my answer. My answer is n is greater than or equal to 11. So I want to pick any number greater than 11 to plug in here and see if my inequality sign is correct. So I can pick 12, 13, whatever. I'll do 12, and we want to see if this is truly greater than or equal to 19. So 12 plus 8 would be 20. And then 20 is greater than or equal to 19, so that is correct. I know this seems like a tedious extra step, but when we get into the next lesson where we're multiplying and dividing with inequalities, you'll understand why this is a necessity. For now, trust me, we do need to do this step to check our work. I want to emphasize the n is greater than or equal to 11 is the actual answer. This entire page, all we're doing is checking the answer to see if we did the answer correct and the inequality correctly. All right, next problem. Negative 26 is greater than y plus 14. Go ahead and separate your two sides again with the inequality sign. This time the variable's on the right along with the 14. So the 14 is the number that I want to move. It's attached with addition, so I'll subtract 14 on the right, and I have to do the same on the left. So then negative 26 minus 14 would be negative 40. Bring down my sign, bring down the y, and the 14 minus 14 cancels. Now this answer would be correct. However, typically you see answers on a multiple choice test, stuff like that. You see the variable first, so I want you to get in the routine of putting that variable first. Put the y over here and the negative 40 over here. Since we flipped their position, we also have to flip the inequality, so it's going to be y is less than negative 40. These two things mean the exact same thing. It's just that I put the variable first, and since I flipped the y and the negative 40, I also have to flip the sign. So now, just like before, we need to check the answer and check the inequality. So I think the answer is y is less than negative 40. So first, let's just see if negative 40 is correct. So I want to see if these two sides are equal to each other. This is negative 26. Negative 40 plus 14 is negative 26. Those are equal, so that's correct so far. On the right-hand side, I have my original inequality again, but I want to choose a number, any number, that's less than negative 40. So be careful. Think about a number line here. That would be negative 41. That could be negative 42, so on and so forth. I'll just pick negative 41. So negative 26, I want to see if that's going to be greater than negative 41 plus 14. This is obviously negative 26. And then this would be negative 27. And if you think about a number line, yes, negative 26 is greater than negative 27. All right, another example here. N minus 15 is less than 3. Separate your two sides. The n is on the left along with the 15. It's attached with subtraction, and that subtraction sign goes with the 15, so the inverse would be to add 15. And I do it on both sides. Bring down the n, negative 15 plus 15 cancels. Bring down your less than sign, and then 3 plus 15 is 18. So I think that the answer is n is less than 18, but again, we need to check the answer and check the inequality. So just check the 18 first. This is my original problem. I plug in 18 in place of n and see if that's equivalent to 3. So 18 minus 15 is 3. That is equal to 3, so that's correct so far. Over here, back again into my original inequality, except this time I want to pick any number that's less than 18. So 17, 16, 15, whatever. I could easily just pick 15 because that's less than 18. And this is a really easy problem to solve then. It would be easy no matter what, but 15 minus 15 is 0, and I can quickly see that 0 is less than 3, so that's correct.